Our planet Earth is a dynamic and ever-changing world. From the towering peaks of the Himalayas to the deep oceanic trenches of the Pacific, geological forces shape our planet's surface. One of the most powerful and awe-inspiring manifestations of these forces is the earthquake. Earthquakes occur due to the movement and interaction of massive sections of the Earth's crust, known as tectonic plates. Imagine the Earth's surface divided into puzzle pieces, with each plate slowly gliding and shifting in response to the underlying forces within the Earth. There are three primary types of plate boundaries where earthquakes commonly occur: convergent boundaries, divergent boundaries, and transform boundaries and transform boundaries. Convergent boundaries occur when two plates collide. When an oceanic plate meets a continental plate, the denser oceanic plate typically sinks beneath the continental plate in a process known as subduction. The intense pressure and friction generated as the plates interact can lead to the buildup of stress over time. Eventually, the accumulated stress becomes too great, and the rocks along the fault line rupture, releasing an enormous amount of energy. These subduction zone earthquakes often result in devastating tremors and are responsible for the formation of some of the world's most spectacular mountain ranges, like the Andes in South America and the Himalayas in Asia. At divergent boundaries, plates move away from each other, creating gaps that allow molten rock or magma to rise from the mantle. This process forms new crust and leads to the formation of mid-ocean ridges. However, as the plates separate, tensional forces build up, causing the lithosphere to crack and fracture. The release of accumulated stress along these fractures results in earthquakes. Although generally less powerful than those at convergent boundaries, these underwater earthquakes can still shake the ocean floor and may be accompanied by volcanic activity. Transform boundaries occur when plates slide horizontally past each other. Along these boundaries, the plates grind against each other, generating intense friction. As the stress along the fault line surpasses the frictional forces holding the plates together, a sudden release of energy occurs, causing an earthquake. One well-known example of a transform boundary is the San Andreas Fault in California, where the Pacific Plate and the North American Plate slide past each other. The frequent seismic activity in this region reminds us of the immense power and unpredictability of earthquakes. While tectonic activity is the primary cause of earthquakes, volcanic eruptions can also trigger seismic events. As magma rises to the surface, it can cause surrounding rocks to fracture, resulting in volcanic earthquakes. It's worth mentioning that human activities can also induce seismicity. Mining operations, the construction of large reservoirs, and hydraulic fracking can all alter the stress distribution within the Earth's crust, occasionally leading to localized earthquakes. Understanding the causes and characteristics of earthquakes is essential for the field of